Hello and welcome. Today I'm going to be talking about the surprising value of a function to do nothing, which is a slightly clickbaity title, but I think if you watch, you'll agree that it basically works. So I'm going to be talking about a couple of situations. One is more commonly known, the other is, I think, quite a bit more obscure, where having the right kind of function that does nothing, that doesn't change any of the values in your calculation, can actually change something from not working to working in Excel. So I'll start with a simple example. Let's talk about the EO month function. So let's say you want to build a dynamic model. So you've got, your start date is January 1st, 2024, and you want to have 12 months. So your month start dates, you could say E date is going to be from there, we'll go, uh, so a sequence of 12 starting at 0 means first we'll have that date 0 months away, then 1 month, 2 months, 3 months, all the way up to 11 months away, which will give us a total of 12 month start dates. And that works just fine. And then you might say, okay, well, I want the end of each of those months, so I can use EO month, end of month, which takes a start date and a number of months. And if you just give it 0, it'll give you the end of the month you're in. And oh, hang on, something's wrong. That breaks. This is something you. This happens for I think about a half dozen or a dozen functions in Excel, um, where they look like they should behave fine with dynamic arrays, but they don't. Um, but the interesting twist is that if you poke them a little bit, they will behave fine. And this is where the function that does nothing comes in. So for whatever reason, EO month and a handful of other functions don't like to work in their first argument, in the date argument, with an array. As you can see here, edate is in the same category, but it's happy to work with an array in the second part, but not in the first. Sorry, with a range, I mean, in the second part, but not in the first part. Um, so the twist is it's not happy to work with a range, but it is happy to work with a calculated array. And so if you do something to this that turns it into a calculation rather than a reference to a range of cells, then it will behave. So for example, if I multiply this by 1, that turns this into a calculation with all the same values in the same order as before, and now suddenly EO month is happy to behave. Other things like that you can do, you can add 0, and it'll do the same. The one that I've most commonly used in my life is minus minus. So you just make it negative and then and then make that negative again. It brings it back. Those all make no change to text. The other one that you can use, and most of the functions that have this feature uh, are ones that expect numerical arguments, but there's at least one that I can think of that expects a text argument. And so there is one. So this will only work with a number, and 0 plus will only work with a number, and 1 times will only work with a number. But if you just put a plus in front of it, that it's kind of the most nothing doing function of all. It's not even doing any calculation. This plus in front of a range reference literally just converts the range reference into a calculated array, and then that behaves. So even if your array is text, it will still work. So just I don't think this is a complete list, but these are some of the other functions that have the same property. I think it's something of, someone told me that these are like functions that were imported from the analysis tool pack or something like that, but they were written in a different way from other Excel functions, and so they behaved differently when they got imported into the land of dynamic arrays. So that's edate, isodd, isEven, n, t, and yearfrac. Um, so that's those. The other one to mention, it's a little bit different from the rest, is at. So I guess a quick explainer on this if you haven't come across it. In the land before dynamic arrays, if you pointed a single cell at a whole column, uh, it would give you the intersection of the column, sorry, at a whole row, I mean, it would give you the intersection of the column you were in and that row, which would be just this cell here. And if you did the exact same formula over here, it would give you just this cell here. And likewise, if you pointed at a column, it would give you the intersection of the row you were in and that column. And if you pointed at a column range when you were outside the range, like you pointed at this column from down here, I think that would throw an error. The way to get that back, because obviously now if you point at a whole range, it spills and returns everything in the range. But the way to get that old behavior back is with the at symbol. It's what's called the implicit intersection operator. So in other words, it takes the intersection of the range that you're pointing at with if it's a row with the column you're in, if it's a column with the row you're in. And I think it just doesn't, I actually don't know what it does if you point it at a 2D array, but I guess we could find out pretty quickly. Let's find out. I think it might throw an error. Yes, it throws an error. Anyway, so that's that. But a little, this is really only for the sort of hardcore short coders, but a little feature of at is that it can only do an implicit intersection based on the row you're in or the column you're in if it's pointing to a range. So if you point at a calculated array, like say sequence 5, it just returns the, that's not showing right because it's a date format, but it just returns the first value of the sequence. And that might seem unimportant, but you can do some funky things with it. So before I go into the second use case, quick aside to show you. This is an Excel challenge from a LinkedIner. Oh gosh, I've forgotten his second name now, but Omid posts um, a regular Excel challenge, I think every other day. And the challenge for this one was to basically standardize a series of product IDs with a bunch of replacements. So for example, all the X dashes had to become P1, Y dashes become P2, M dashes P3, spaces become dash, and then all these other punctuations become dash as well. And the key to it was that you had to repeatedly apply a substitute to replace this with this, 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 and so on. And so you sort of have to, you can use reduce to repeatedly apply a function. And so this is a one standard way to do that, which is you reduce starting from the inputs, and then you need to take whatever number of rows there are in this, and there's 8 rows in this, so you need to take 8 steps. So 1, 2, 3, 4, 5, 6, 7, 8, and then at each step, you take your starting thing and you substitute, you know, the entry from this column for that step with the entry from this column for that step. So one quick aside on this is just Owen Price recently shared a couple of cool. Whoops! No! Stop! Sorry, I'm hitting the wrong buttons here. Here we go. Shared a couple of cool lambdas based on F#, I think. One of which was list.fold2 and reduce2, which is basically a reduce that lets you operate over 2 arrays of inputs instead of 1. So this is a very, very simple problem with his reduce2. You can just say operate over this column and substitute already takes the arguments in the right order, so you can just plug in the native function. But Bo Ridabon, Excel Wizard, shared a solution using this at plus logic. So like I said, at, if you refer to a calculated array, returns the first element. And so if you put plus in front of a range reference, that gives you the first element of that range. So at plus is basically a kind of extremely compact way of writing index range 1, 1. Give me the first row, first column. And so what he did was he had reduce iterate just on the second column, and then for any given element in the second column, to get the corresponding element in the first column, he took the range, let's say we're at P3, he took the range from P3 to the bottom of the other column, and then took the at on that to get the first element. So it was basically a way of shifting 1 over without having to use offset or index or anything funky like that. Like I said, this one's a pretty narrow use case. If you were going to use it for client work, you'd probably want to err on the side of something that was a little easier to read. But it is just kind of magical to see the things that Bo is able to come up with. So I love that one. Thought I should mention it. Anyway, so that's the first set of functions to do nothing. I'm going to kind of park that topic and then switch to something that some friends and I were discussing, I don't know, at least a year back, which was trying to dynamically get a series of offsets. So in this case, I've got, starting from the T, I want to offset by 1, 1, 2, 2, 3, 3. So I want to get a sort of stair step coming from that T. And so I've just got my kind of sequence of 3 here, and I can easily do it with 1 cell at a time, just offset by that many rows, that many columns. But if you say offset from here by that many steps and that many steps, it throws 3 value errors. Kind of confusing. so what we discovered at some point was that if you take this and wrap it in a function, so you can't just do something like that. That still gives an error. But if you feed it as the input to a function, don't ask me why, then it brings out the numbers. But then we were trying to figure out what functions could we possibly use. Well, if you know that it's all numbers, you could use this. But if you've got, like I have here, a grid that's a mix of text and numbers, then let's say we want to offset from here instead. So now we're picking up these three values. Let's just color those in. So then n is obviously not the right function to use for that anymore, but we can use t just to return the text of a cell, and that gives you that. And then you could sort of hack a solution together based on that by saying, you know, if like if n of it is 0, then give me t of it, or if t of it is blank, then give me n of it, or something like that. It gets kind of ugly, but you could make it work, and that's basically where we left it a year ago. And then a lot more recently, I don't remember exactly when it came out, I was watching this video by Owen Price about using Excel's pivot by function to fix your data structure. And the idea was basically that you wanted to kind of take this data over here where you have, you know, a list of values for each of several projects, and then you've got, you know, multiple different attributes here. So in other words, for this blue block is one project with a project code and a department and a vendor and so on, and he wants to spread it across a row and then spread the second one across another row and so on down. And so Owen was demonstrating how to do this with pivot by, and I was watching this, and he said, well, you know, if you use max, then it'll give you the numbers, but it won't give you the text correctly. And if you use t, it'll give you the text, but won't give you the numbers correctly. And I was expecting that he was then going to say, well, you know, you could do some weird combo of the n and the t and blah, blah, blah. And then instead, and hopefully you'll be able to hear the sound here, he said this. Now, up to there, I thought, oh, that's interesting. I've heard of the implicit intersection operator. Not sure how you would apply it here. And then now this I had absolutely never heard of, that there is actually a function that corresponds to that little at symbol. And because there is a function name, you can pass that function into other functions that take function arguments like pivot by and other Lambda helpers. And so I basically fell out of my seat at this moment in the video, and immediately thought, wait, does that mean that I can take this crazy idea and use it with this offset? And it turns out the answer is yes. So if I use map all this stuff single, in other words, apply the single operator to each of the values here, it gives me exactly what I want. And if I then have numbers, it gives me exactly what I want. And if I then have, let me find somewhere with mixed, I should have planned one, but never mind, here's one. Somewhere with mixed input, it perfectly gives me, without even kind of coercing the 9 into a number as text, it gives me the exact output that I want, which is kind of crazy, but there you go. And that already blew my mind, and I've used this. Well, so sorry. So this offset is the context that I came across this in, and then separately in an esports battle, I came across this situation where I have a series of cell references that I want to take an indirect of. So let's say I want to get what is in each of these cells on this other offset tab. So you could say indirect of offset, the name of the tab, with an exclamation mark, and that, and it'll pull each of them in. So we'll call it multi-cell, multiple cell formulas. I don't know. But if you just wrap a range in indirect, it doesn't behave. And so I literally hit this, like typed indirect of a range on the day in the competition, saw a bunch of value errors, and had a flash of, wait a minute, could that crazy map single trick work here? And it turned out it does. So you can also, in this situation, when you want to indirect a range, you can wrap that in map single as the remarkably powerful function that does nothing. And then the last piece of this is that in one of Bo Ridabon, Excel Wizard's recent videos, I discovered that there's another way to do this, which is he does it using the cell contents function. So it's not the most commonly known function, but you can get various attributes of a cell, like the width or type or row, prefix or parentheses or format, blah, blah, blah. The one I've most often used it for is file name. You can get the cell of a file name. So here it gives me blah, 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 the function that does nothing.xlsx with some weird thing because I'm on OneDrive, I guess. But you can also use it to get the contents of the cell. I have no idea in ordinary times why you would want to use cell.contents of blah to get that rather than just pointing directly at the cell. But again, the power of a function that does nothing, in this case, it works. So if you say cell contents of that indirect, or equally if I do it over here for this offset, you can say cell contents of that offset, and it gives you back those three values. Like I said, this one I at least have some sense, like someone explained to me that these functions were written separately in the analysis toolpack and then imported into kind of main Excel. This one I have absolutely no idea what's going on under the hood. I would be fascinated to hear if anybody does know what's going on under the hood. But what I do know is that using either single or cell, you can make offset and indirect work with arrays in a way that they otherwise are not willing to do. So I thought that was pretty cool. That's what I got for today, and I will be back pretty soon with my next big project, I hope. But I'll tell you more about that in a couple of days. Thanks for watching. See you next time.